Okay, welcome to grade 9 math. We're in unit 4 linear relations and lesson 3 talking about changing conditions, how some things in our graphs may change and what that means to how they're going to look and how we can draw them. By the end of each of this class, we'll review creating equations for linear relations. We'll describe the graph of linear relations, how it would change with the initial value or the rate of change being varied or changing. All right, so Julie usually walks to school. The distance time graph that represents her trip is shown here. One day, Julie stays over at Jessica's house. Jessica lives closer to the school, and that morning, her mom drives. Her mom drives them both. So, how would the distance time graph of Julie's trip to school change? Which graph would represent it better? So, if she lives far from the school, then her friend must live somewhere closer, right, in this range. And we did talk about yesterday, the last lesson, how the steepness means the speed. So if it's, we'd be looking for something steeper if you're driving, I think, because she walks usually, and now she's going to get a drive. So I would say that we're in the range here of a steeper line, right? So if you were to put this line up here, right? Oh, right? That's what we're going to look for, something like that. So not this one, although it's closer. Not this one, still far away. This one's slower. So definitely um, we're looking at D being the option. So starting at Jessica's house, driving faster to school. That's the type of thing we're going to think about today and look at interpreting different lines. Okay, here we go. So linear relations can be described with an initial value and a rate of change. If either of these conditions change, the graph and the equation will also change. The flag is at half mast and is lowered at a rate of 80 centimeters per minute. The flagpole is 10 meters high. The graph that represents the situation is shown below, and the equation that represents it is y equals 500 minus 80x, because look at 80, okay, where x represents the time in minutes and y represents the flag's height of above the ground. So where did we get the 500? Well, there's our initial value. Remember, we called initial value b, and rate of change was an m. So here's our b. Okay, our b, and our rate of change was m. There's our m, where x represents. Good. So what would happen? How would the graph change if it was lowered at a speed of 50 centimeters per minute? Draw the line. Okay, so if we had, let's do a different color here for A. So if we started, again, it didn't tell us about changing anything about the starting point, but if it started here, how would that change our rate? So it's going to go 50 centimeters. This is our centimeters per minute. Okay, I'm finding it hard to pick in between here. So if we were going 50 centimeters, then it would be 100 centimeters per 2 minutes. And that might be easier. So we could have a rise of a down 100 and over 2. If you just keep doing that, down 100 over 2, down 100 over 2, down 100 over 2, finally down 100 over 2, then we can start to see, yeah, look, it's less steep because it's a slower rate than 80. So the new slope is less steep. It's also slower. Okay, the new slope is, so we can graph that. I'll just add a line there. All right, good. So now we've seen what happens when the rate of change or the slope decreases, it goes less steep. Next, how would the graph change if the flag started at the top of the flagpole? Remember, right now, 10 meters is the height, the total, and it's only at half mast. So let's pick a different color here. So top of the flagpole was 10 or 1,000 centimeters. And the rate stayed the same, so same. So we're only changing one factor at a time here. All right, so if we went up to the graph now, with our blue line, blue color, and we're still going down 80 every minute. Okay, so I wonder if we can pick maybe a number that goes well with 80. Like 80, when's the next big whole number we could get? So, um, we're thinking 800. You could go to 800. But how many would that take? That would take over 800 in how many minutes? Well, that makes sense. 800 divided by 80 is 10, obviously, right? So 800, you want to get nice, easy numbers, is 10 minutes, at the 10-minute mark. So if we could get to down by 800 over at the 10-minute mark, now that doesn't bring us to 0, but that gives us 2 points. We could have used 40 also. 40, 400 divided by 80 would have given us 5, right? We could have did that. I'm just looking for nice numbers that 8 goes into or 80 goes into. 80 doesn't go. We don't want to do. We don't go by. We don't want to go by 80s or 160 or 240. That doesn't really work out very well. So if we did 400 or 800, that's when the 80 hits nice big numbers like with zeros. So we could also do that. So from 600, so 1,000 minus 400 is 600, and at the 5-minute mark. And look, that does form a nice line there. Extend that right through. And maybe we could adjust it a little bit at the top there. It was a little off. But there we go. Okay, so what happens then? Well, obviously it takes longer. But we say that the vertical intercept, that's what we notice, the intercept, that's an intercept, okay, is higher. Is higher. Okay, but the slope is the same. All right, could we come up with a new equation? We had our original equation here. And so could we come up with a new equation? Well, if B is the starting point and M is the slope, can we figure that out? Well, they gave us a slope here. So in A, we had the same starting point. We had a new slope. And so we could say y equals 500 minus 50, x. Okay, whereas the blue line we had the B changed. The B changed to 1,000, and the M stayed the same as the original at 80. So y equals 1,000 minus 80x. So some things we can notice is we remember some terminology like this is the coefficient. So the coefficient changed. This is the constant. So a couple things that we could say. We can say that the rate of change we are going to call slope, and it is indicated by the coefficient. All right. Whereas the initial value it tells us the vertical intercept. Oh boy, jumped. Intercept, and it's a constant, meaning no matter uh, how much time passed, we always started at that same point. All right, so that's good. Good terminology there. All right, next. All right, we are looking at a table of values. So here is a table of values. So sometimes it's good not just to take it from only an equation or a graph, but use a table of values at some point. The table represents the cost of printing yearbooks. Create a graph and an equation to represent this linear relationship. All right, so we might want to have total costs and number of books along the bottom. Okay, so create a graph and an equation to represent this linear equation. All right, so how can we graph this? So we're going to graph these points along the way here. All right, so we're going to represent this. 50 yearbooks is going to cost 1,500. All right, check. Did that one. 75 yearbooks. 75 is a little tricky because this is 70, this is 70 and 80, so we're right along here at 75 is 2,000 books. Okay, now 150. So if this is 160, 140, we're here at 150. And that's going to cost us 3,500 books. Good. All right. So we can't make the equation yet. We can make the graph. The equation will help to know where this goes. So trust your points because it didn't tell us anything about going that 0 books cost $0. So trust the line. You can only go by what the line gives you. You're not going to curve that line at the end just to make it go to 0, 0. And in these cases, it doesn't make sense to do that because we want to see if there's an initial value. So in this case, look where our initial value is. We call that B. So what's our B? Our B is 500. So we must, to set up a yearbook for the year, you must have to pay $500 maybe to pay for shipping, pay for art design, pay for the graphics program it was to design it. Who knows? So there could be a whole assortment of different things that we need to do. Now, how are we going to find the slope or the rate of change? Well, let's take one segment at a time here. How much do we rise right here? Okay, that is a rise of 1,000. And then a run of 0 to 50. So we have a rise of 1,000 divided by a run of 50. And we don't need to do this all along. We just need to do it in one section that we can see really clearly. So 1,000 divided by 50, I should make that look like a 0, is 20. So $20 per book beyond that. So it costs $500 to set up the yearbook for the year, and then $20 per book. So we can come up with an equation now. The total cost of y equals 500 to start plus $20 per book. This is the number of books, x. This is the number of y, total cost. That's why it works with the axis. Okay, so that's kind of our base now. We're going to use this as our basis of comparison here. So now we go to B, and we're changing one or the other thing. If the cost per book is increased, give a possible new equation and draw the graph. What do you want to say? Let's not go crazy here. Let's just say let's say we make it a $25 book. How's that going to change? Well, now y will be the same. We still are paying 500 to start the book, and we have 25x. Now, what will that look like? So at 500, so let's make big jumps here. So let's say, what would be 100 books? Let's say so 100 books. Sort of. I always find like you pick somewhere in the middle, pick a nice number in the middle, go and do 25 times 100. Okay, plus your 500. What's that going to equal? So y is going to equal 500 plus 2,500. So y is going to be 3,000 in this case. So we can chart that now. So at 100 books, okay, we should jump. Now we are factoring that in. So we're going to jump up to 3,000. There we are. So what's that line going to look like? And we can extend it right through. A line that's blue. Starting at the 500 and passing through that point. So steeper, right? Makes sense. Our rate of change is higher, so our line is steeper. And that's what we're trying to get to today, is visualizing how these changes will occur. All right. So let's look at what if we changed the vertical intercept? We changed the fixed cost. What if it decreased? What if we made it 0? We didn't even have to pay the upfront cost to build the yearbook. We just paid a different amount at the bottom. Well, it's not actually saying that. So we're not going to change. So we're only changing the fixed cost is decreased. Give a possible new equation. Okay, so All right. So let's say we had 0, a b of 0, and our rate back to the beginning was still 20. So we could have y equals 20x plus 0. Better yet, let's write it in the same order that we were writing before. 0 is our initial cost plus 20x. So maybe just simplify that. We don't need to write that, 20x. Although if it helps you to keep that there, to remember what your y-intercept is or your vertical intercept is, that's fine too. So let's say we started off at 0. Again, pick a point like 100. That's convenient. So do some math on the side here. 20 times 100 is 2,000. Okay? And so that's where we're going to be. We're going to be at 100 and 2,000. And you could do that again, go another 100, but you'd be way up here. If you've got a good ruler, you're going to be fine just graphing this. So bring this through. And what do we notice? Well, that's great because our y-intercept changed, but our slope stayed the same. And notice that if our slope or our steepness is the same, these two lines from the original to this third option, they stay the same distance apart the whole time because the rate didn't change. They had the same steepness. Only thing was, let's say the principal decided, oh, I'll cover the $500. You just charge the students the minimal amount, $20, right? So no one's making money off of this, for example. Okay, so that's how we can change these factors and how that will affect our line and what it would look like in our steepness. So that's today's lesson. You have plenty to practice with this. So here again, you'll draw a line and you'll have certain factors change and coming up with an equation. Everything we talked about today. Again, different options here, different initial values and rates. You'll graph it. You'll see what changes if your rates change. Again, comparing different rate changes, what would apply, and more interpretations there. Okay, so that's today's lesson. Thanks for watching, and get lots of practice in.